Evidence for evolution, most of them are looking at structures of organisms and making comparisons by looking at how organisms are put together, bones and muscles. So we have three major types of structures we look at. First one is homologous structures, common function, common ancestor. So if we were to make a comparison of a human arm to the leg of a horse, it would be the same structure: humerus, radius, ulna, carpals, metacarpals, phalanges. Analogous structures are common function, uncommon ancestor. So an example would be a bird wing and an insect wing. Both provide flight for the organism, so we have a common function, but the structure is very different. So that suggests an uncommon ancestor. If we look at a bird wing, it's made out of muscle, bone, feathers, tendons, and ligaments. If we look at the wing of an insect, it's almost like a modified skin piece that comes off the back, yet provides flight for the organism. Common function, but uncommon ancestor. Vestigial structures are stuff inside of organisms that's useless for their survival, but suggests at one point it was useful. That helps us to kind of set up some sort of possible ancestor that might have used it. A whale, so an example for us would be an appendix or a wisdom teeth are useless for our survival, but at one point we probably used it. So that suggests that we were more of a vegetative consumer. We needed more teeth, and we needed appendix to break down different types of vegetation. We find femurs and patellas and pelvis in whales. So this suggests at one point they might have been land-like creatures because they had leg bones. Macromolecules is something we're not going to get into right now. And embryology is looking at embryos and making comparisons so we can suggest some sort of relatedness of organisms to each other. This is an example of homologous structures. If we look at a bat wing, a dolphin flipper, an anteater leg, a mole arm, the leg of a horse, the leg of a pig, leg of a monkey, or an arm of a monkey. So if you look at their arms, it's all the same: humerus, radius, ulna, carpals, metacarpals, and phalanges. If we look at their leg, they all have femurs, tib, fib, tarsals, metatarsals, phalanges. All the same, so homologous structures. Another example, homologous structures, just showing all the bones: humerus, 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 humerus. All of them have a humerus, radius, ulna, phalanges, metacarpals, carpals. Horse, alligator, bat, porpoise, and human. Analogous structures, all these provide flight for the organism, but all are different structures. So we look at a piece of skin coming from an insect that provides flight. We look at a wing from a lizard. We don't really have flying lizards anymore, but dinosaur time, they were around. A bird wing, bat wing, all very, very different structures, yet provide flight for the organism. So analogous. This is just showing all aquatic organisms have similar structures because they live in the water, but yet are very different from each other. A fish, a bird, a mammal, all have relatively the same type of structure, but all are different in how they're put together. Another analogous structure would be a platypus and duck. Very, very similar like structures, but very different. One's a mammal, one's a bird. Vestigial structure, this would be a femur, the remnants of a pelvis, a patella inside of a right whale. Why does it have a leg? Maybe at one point it needed it. Its ancestors lived on land and needed legs. Vestigial structures in humans, you have a little point on your ear called Darwin's point, useless. Plica semulinaris is the little red dot on the inside of your eye, which is the remnants of your third eyelid. Pineal gland is used for organisms that change color during the winter. Wisdom teeth, appendix, body hair, all these are useless to you. Males have nipples. What's up with that? Don't need them. This is Darwin's point. This is what it looks like in a monkey. This would be what it looks like in you. Appendix, where your small and large intestine meet. You have this little outcropping. Useless. That's your third eyelid. That would be one in a cat. This is embryos. Okay, so this is just showing that mammals look very similar to each other compared to lizards, but we all look relatively the same early on as vertebrates,